Advanced Math Lesson 99, Sequence Notations, Advanced Sequence Problems, and the Arithmetic and Geometric Means. So the first thing, which is sequence notation, this is kind of like a review thing again, but just to reiterate, the notation for our sequences is that in an arithmetic sequence, the amount at now is equal to the amount first plus the number now minus 1 times d, which is the arithmetic mean. All right, so d is the arithmetic mean, a sub 1 is the first term, a sub n is the current term, and then n would be like, the number of the term. So if it were a sub 10, that would be the 10th term, n would be 10 minus 1, which would be 9, and same follows here. So this is the notation. These are the formulas we use for solving geometric sequences and geometric means. Let's go on to a practice problem. So the way this is going to get more difficult is we're going to start doing geometric progressions that don't have our traditional numbers. They'll be algebraic expressions. So let's do example 99.2. We have to find the fourth term. So we have to find the fourth term in a geometric progression that begins with the first term being 2 plus root 6. Then we have 6 plus 2 root 6. Then 12 plus 6 root 6. All right, so these are the first three terms. We have to figure out what the fourth term is. We could try to use some logic and try to figure out what the trend is in change and try to guess what the fourth one is. Or we could use the same way that we would do it with whole numbers, is we'll just take two adjacent terms and then divide the latter by the former. So I'm going to take 6 plus 2 root 6 and divide it by 2 plus root 6. Now, in order to divide this, I'd actually have to multiply by the conjugate to rationalize the denominator. So this whole thing is going to get multiplied by 2 minus root 6 over 2 minus root 6. From here, what happens on the denominator is the middle terms cancel, so then I get 4, or it's kind of like the product of two squares, similar, because it's the opposite of difference of two squares. So I'd end up getting 4 minus 6, which gives me negative 2 for the denominator. For the numerator, I have to actually FOIL this. So for the numerator, I have 12, 6 times 2, and then I have plus 4 root 6, and then I have minus 6 root 6, and then I have plus 12. So that's going to become 24. Wait, was it plus 12? No, it was plus 12. Okay. So that's going to be 24, and then that's going to become negative 2 root 6 over negative 2. All right, so then if I take 24 minus 2 root 6 over negative 2 to divide this, that's going to become negative 12 plus root 6. I feel like I did something wrong here. No? Did I multiply this right? I think I followed this wrong. Hold on, let's pause and let's examine. Yeah, I did something wrong. I caught it. This last one shouldn't have been positive 12. It should have been negative 12. I thought I stuttered when I was doing the 24. So positive 12, negative 12 cancels. So it's just negative 2 root 6 over negative 2. Way simpler than all this stuff I just did. Okay, so sorry about that. So what this simplifies is to negative 2 root 6 over negative 2. Just going to cancel and then be root 6. Okay? So once I take the first term and I divide it by the second term, or two adjacent terms, and I divide them by each other, then all I have to do is multiply the next term by this number, right? So to get the fourth term, I take the third term, or I can plug it into this equation. So to get the fourth term, I'll take the first term, which is equal to 2 plus root 6. Then I'll add that to 4 minus 1, which is 3, times root 6. And this will give me my answer once I simplify it. So 2 plus root 6 plus 3 root 6 is going to be 4. 2 plus 4 root 6? feel like I'm discounting this somehow. Oh, that's the arithmetic sequence. That's what I did wrong. Sorry. Geometric sequence is a sub 1, 2 plus root 6 times the arithmetic mean of root 6. That makes more sense, to the exponent of 3. I was like, shouldn't I be multiplying root 6 by itself? Okay, so root 6 to the exponent of 3 is just going to become 6 root 6. All right, so that one's done with. 6 root 6 being distributed to this. 6 root 6 times 2 is, we'll put it here, 12 root 6. And then 6 root 6 times root 6 is going to be 6 times 6, which is 36. So 12 root 6 plus 36. That will be the fourth term. Whew. Okay. So this is the arithmetic sequence. This is how we do it with other things. There's a lot of algebra involved here, which has been a little while since I've had to focus on that. So make sure you keep track of your radicals. Make sure you are foiling correctly. My mistake from foiling here came because I just didn't want to write everything down. I was trying to do it all in my head. So if you need to, write it down. And then when I stopped and checked my answer, I realized what my issue was. So save yourself a little time. If you need to write it down, write it down. There's going to be a little bit of work in algebra on these problems. But that's it for geometric means. The last thing that we'll talk about is the arithmetic and geometric means in a problem. So we'll look at example 99.6. They tell us the positive geometric mean of two numbers is 8. The difference between the numbers is 30, and we need to find the numbers. So what we have here is two numbers that are 30 units apart. So we'll say we have number, and then we have number plus 30. Right? That's a good way to say it. And their geometric mean is 8. So if we take number times 8, we get number plus 30. I believe that's what we're talking about. Oh, no, I'm sorry. No, if the geometric mean is 8, I'm sorry, then it's n times n plus 30 is equal to 8. No, it's the square root. Sorry. Okay, real quick. Let's do some background information before I even try to solve this. So the background information is that in order to find a geometric mean between two numbers, let's say the numbers are 4 and 20. So let's say I have the numbers 4 and 20. This is a sub 1, a sub 2, and I need to find the geometric mean between them. What I do is I multiply them by each other and then find the square root of that. So I take 4 times 20, and then I'd square root that. So that would be like 2, and then that would be 4 and 5, and then that would be 2 and 2. So it'd be like 4 root 5. Okay? Hold on. Yeah, sorry. I thought I did something wrong with the radical again. Okay, so that would be 4 root 5. So what they're saying is that the geometric mean, that's where I did it. So the geometric mean 4 root 5 makes 4 a sub 1. 4 root 5 would now become a sub 2, and then 20 would be a sub 3. Okay, so that's what a geometric mean does. It inserts itself in between two existing numbers and kind of bumps the one on the right over one. So it's like the middle number through multiplication. Now, let's go back to our problem. So we have two numbers that are 30 units apart, and they've got a geometric mean of 8. So if I take number 1 times number 2 and then square root it, I'm going to get the number 8. The easier way to do this would be to square both sides and just make this 64, though. So if 8 is 64, and then I have n times n plus 30 equals 64, I would distribute this to get n squared plus 30n equals 64. From here, I could set it equal to 0 and see if I can use the zero factor theorem. So now I've got n squared plus 30n minus 64 equals 0. Doesn't look like zero factor theorem is going to work because I can't think of anything that is a factor of 64 that will add up to 30. Oh wait, no, 2 and 32. Yeah, okay. So I could factor this. So it could become n plus 32, and then n minus 2 equals 0. So then using zero factor theorem, n is either negative 32 or 2. And these are my my possibilities. These are my two numbers. These are my two numbers that are 30 units apart that have a geometric mean of 8. Whew. Okay, so quick recap. For the geometric mean, you're kind of like inserting a number right in between the two existing numbers. In order to do that, you have to multiply both the numbers by each other, then find the square root to figure out what that number is. If you have that number and you're trying to figure out the two numbers, then you set the two numbers as an equation equal to that number, square both sides, and then start solving. You may have to use quadratic formula. You might use factor theorems like I just did. But that's the gist of the advanced sequence problems and then arithmetic and geometric means. Whew. All right, if you guys have any questions, let me know on the school website. I will see you in class.